We've reached the last part of Unit 9 and we will start with asteroid biotransformation. For that, we should remember two main concepts: what is an asteroid and how they're synthesized in the industry, mainly by biotransformations, or actually transformations involving biological units, either enzymes or whole cells or microbes, and as the concept, or also chemically with chemical modifications. Regarding asteroids, we should remember that these are small molecules, part of a family of terpenoid lipids, which suppose in the market more than $10 billion. So it's a kind of interesting sector of the pharma industry. Mainly, sex hormones are corticosteroids are synthesized both in a chemically way and employing microbes. And for sure, employing genetically modified organisms and genetically improved enzymes to produce these asteroids. The goals of these transformations are mainly to improve the activity and the traits of the already available compounds, and as a source of new asteroidal compounds. We will see that the microbial processes for asteroid synthesis described to date are mainly three. Microbes can be used as a source to produce intermediates, okay, that are called these synthons, and these intermediates will be used later as key precursors to produce final asteroids. Imagine that this esterol, naturally produced by mycobacteria or another kind of fungi, can be metabolized and bioconverted into an intermediate asteroid compound that will be a precursor for the final compound. A second role will be the functionalization of asteroidal compounds. This involves the bioconversion of one asteroid used as a substrate, which by the action of mainly enzymes but also whole cells is transformed into a secondary compound. This asteroid normally has a low value in the market and a simple structure, whereas this one has a really high price in the market. And the bioconversions normally regarded here are normally isomerizations or redox reactions, some reactions that are pretty common among the metabolic versatility and biochemical properties of microbes. The third bioprocess will be the synthesis of new asteroidal compounds. This de novo biosynthesis can be, for example, the case of the hydrocortisone, which is made from non-steroidal substrates. In many occasions, several microbial strains, especially mycobacteria, but also these fungi, are used as microbial cell factories to produce key asteroidal intermediates. So, actually, the first function is the most common one. Afterwards, normally all these products are submitted to chemical modifications in order to get the final product. And also, not these chemical modifications can be done enzymatically, and they always push you to ease the bioprocessing of the whole product. Such as easing the facilitating downstream processing, or simple media, etc. We commented on in which are the microbes normally used. We said mycobacteria are really relevant because they can naturally metabolize esterols and are frequently used as biocatalysts to transform these phytoesterols esterols produced in plants into steroidal intermediates of high value, but also we can rely on enzymes or which will drive these chemical changes upon the intermediates. This or other these or other microbes which will be capable of introducing regio and ester-specific modifications in order to find and to improve the final product. We can see some examples here.